Yes, sir. Now screen is visible. Please, learner, comment if the screen is visible to all of you. Now, sir, it's visible. You can continue, sir.
Okay. So in today's topic, we are going to learn about the preprocessor. So here, the preprocessor is a program, as I have explained, that processes the source code before the compilation of your source code begins. So the learning objectives are, we are going to understand what is the preprocessor and learn its types, and also we are going to implement the preprocessor directives in our code. So we will understand it through the example code as well. So the preprocessor directive is a program. Sorry, preprocessor is a program that transform your source code before the compilation of the source code begins. Okay, so the main task of the preprocessor program is to perform some kind of pre-processing before the compilation of your actual source code begin. So that is the main task of the preprocessor. So preprocessor is basically a small program which comes when you install the C programming development pack or SDK. So this program is actually, it is not the part of the compiler, but this program is called by the compiler before the compiler begins translating your source code into machine code or some other executable code. So and what this preprocessor does is based on some instruction given to the preprocessor program. So we need to give some instruction to the preprocessor program. Okay, and those instructions are given with the help of something known as preprocessor directives. Okay, so based on those directives, the preprocessor program performs certain operations. For example, we use printf function in our program, but we never write the code for the printf function. Okay, because we use the printf function which is already defined in the stdio.h library. So what the preprocessor does is it includes such kind of function, the source code for such kind of function into your into the source code written by you. So finally that source code becomes the expanded source code. It means this source code now contains the code written by you as well as code from the library, and then the whole code is compiled by the compiler. So because we have already learned in the session where we learned about the user defined function, that in order to use any function, so we need to call this function, and whenever we are calling that function, so we need to first define it, then only we would be able to call that function. But in our source code, we often call printf function, but we never write the source code for it because the code is already written in the library. So before the compiler begin translating the that code which uses the printf function into a machine code, it also needs the definition of that function. So that definition is included by the preprocessor directive from the C programming library. So this is how the preprocessor works. Okay, so this is one of the operations which is performed by the preprocessor directive, and that is to include the source code from the library. The other task also performed by the preprocessor directive, which we are going to learn in the next slides. So now what are the preprocessor directives? So preprocessor directives are basically the line in your source code which begins with the hash symbol. Okay, so any line in your source code, if that begins with the hash symbol, it is known as the preprocessor directive, and the preprocessor program interested in that line only, which includes the hash at the beginning. So that is known as the preprocessor directive. So we give the instruction to the preprocessor program with the help of this preprocessor directive. And what kind of instruction we can give? These are the three types of instructions which we can give to the preprocessor program are specified here. So first instruction we give is to include a file, or we can ask it to perform the macro substitution, or we also uh, uh, do the conditional compilation with the help of preprocessor directive. Okay, so we are going to see each of these in with the example. So in short, we can say that there are three types of preprocessor directives. So these types are used to specify the different types of instructions which we want to give to the preprocessor program. So first we are going to see the file inclusion directive. So file inclusion directive is basically used to any other external file into your C program. Okay, so that external file could be your library file, or it could be your own defined file in which you store the function, and you are going to you want to include those uh, those functions or code which you have already written into your source code. So this gives us many benefits, such as if your program is very large, so you can divide your program into multiple files. Okay, and then finally you can use those files in your main program and include the code of those files in your program. So this is how you can create the modular kind of structure. So where you divide a very large program into small parts of files, where you store the code in the form of functions, and then you can include those files in your program. So this becomes very easy to handle as well. Uh, Another benefit is that if you write the program into separate files, then you can use this code into your one program. You can also include this code into your second program. This is the benefit which the library or the header files also gives us. Okay, so these are the benefits of uh, writing your program across the different files and then including them. So how you can include the file? We have already learned the first way, which is used to include like this. So first way to include any external file is by using the less than and the greater than sign, and another way is to include by using the double quotation mark. So there is a difference between this. So actually, whenever you use the first type of directive, so it means that it will search the specified only in the standard directory, and those directories are the include directory or the library directory. So it will search only in that, and including this type of including the file within the double quote marks will not only search the file in the standard directories, but it will also search the file in all other directories in your current directory. For example, let's say this is your current directory, and in your current directory you have the standard directories as well. Let's say this is the SDK. Okay, GCC SDK. Let's consider this for an example. SDK contains different directory. One of those is the include as well. So include contains all the header files. And suppose you are writing a file somewhere in this directory only .c. So whenever you include any file, with the greater than and less than, within the greater than and less than sign, then the compiler or the preprocessor directive will search for the file only in this standard directory. It will not search anywhere else. But suppose if you have created your own header file and your file is stored somewhere here or within some other directory, some, let's say some user directory, and you have created your file here. So at that time, when you include the file with this the standard method, then you will get an error that this header file cannot be located. So therefore, you have to use the second form of the including the file, and that is between the double quotation marks. So what this tells the preprocessor is that not only search the file in the standard directory first, but also search in the other directories in the current working directory. So this is the benefit. So let me show you one a quick example how you can use this. Okay, so I am going to create one header file here. It is my own header file. So let's say the name of this is the test, or I call it my function .h. Okay, so this is the header file which I have created. Now I'm going to write a very simple code in this function, that is void and then show printf hello from. So let me save this, and then now I open my source file, and here what I am going to do is I'm going to include the header file this, and I'm going to call the function. Okay, so let us now compile this. Okay, so you can clearly see that it gives an error, my func.h no such file or directory, and that this happens because the preprocessor search only the header files in the standard directory. So in order to avoid this error, what you can do is just write the double quotation mark. So in this way, the preprocessor not only search this file in the standard directory first, but after, if it does not find in the standard directory, then what it does, it search the file in the all other directory within the current working directory. So I made a typo error. Okay, so it is giving the error now. So now the code has been compiled. Okay, so you can clearly see. So this is how we can in this way we can use the preprocessor, different types of preprocessor directive for the file inclusion. The another type of preprocessor directive is the macro substitution. So in this macro substitution, what we do is we define some code, and then we use that code in our source code by substituting the that identifier. So in macro substitution, what we do is we basically define an identifier and the code or the value for that identifier. Okay, or code or value for that identifier. And then in our source code, we use that identifier. So when your source code is pre-processed, then after this pre-processing, the expanded source code which you get is, it will contain the value for that identifier which you have defined. Okay, so basically what you are doing here is you are substituting this identifier with the value after the pre-processing. So that is why it is known as the macro substitution, and the identifier which you define is known as macro. Okay, so this is known as the macro substitution because we substitute an identifier which is defined, which is also known as the macro, with its value after the pre-processing. So that is why it is known as the macro substitution. Okay, so there are basically two types of macro substitution which you can use. The first one is the object like macro, and second one is the function like macro. So we are going to see this. So object like macro is nothing but it is a simple macro which has the identifier and any replacement text or value. Okay, so this is known as the uh, object identifier. Okay, so because here we use the value uh, in the form of object. So we are going to see this with an example. Okay. And one more thing which I forgot to mention, that the macro substitution, like we have seen in the earlier slide, we have seen that the file inclusion directive. Okay, so file inclusion directive always, this is the preprocessor direct, so it must begin with the hash symbol, but the file inclusion directives uses the keyword, uses the word include, whereas the macro substitution directive uses the word, predefined word define. Okay, so whenever you use the define, it means you are using the macro substitution directive. Okay, so here I am going to use the macro substitution. Okay, so I'll use the word define hash define, and then I can give any identifier. Remember that this is the identifier. So all the rules which we have already learned to define an identifier are applicable here. So define, and let's say any name I want to give. Okay, so I want to give a name pi, and 3.14 is its value. Okay, so whenever in our program we use pi, okay, so now we can use this pi in our program. So let us compile this first. First save, compile, and then execute. Okay, so you will get the value printed here. So what actually happens is when we compile this code, so after when we start compiling this code, so before compilation, the pre-processing takes place, and what the pre-processing does is it replaces this pi value with the value which we have defined. Okay, so actually your code will look something like this after the compilation. Your code, the expanded source code which the compiler gets would look something like this. Okay, so because uh, the identifier, this identifier is replaced with this value here in place of this. Okay, so this is known as the uh, macro substitution directive. Okay. However, C language not only allows you to define only the value to identifier, but rather than you can use anything to define. For example, I can use any operator. I can use, let's say, if I want to specify any condition, I can use that also. And here, and I can also use any predefined code such as okay, so you can have anything defined as the preprocessor directive. So let's say I'll first call print. Okay, so you will get that printed here. We have not used this print, but we have not used printf function, but we have used print. So when the code is compiled, this print will be replaced. When the code is pre-processed, this print will be replaced with this statement. Similarly, let's say I have two variables and I use if condition, then A and B are 10. Okay, so you will get this message. Whereas if I change the value, then the condition will be false and you won't get anything printed. So this is how you can use this directive as well. Okay, so here I have used this part in the condition as well. So what this does is when your code is pre-processed, then what the preprocessor does is it first replace this condition with the value a less than 10 and b less than 10, it will first replace with this, and then it will replace this with this whole, because we have again used another macro here. So it will then further substitute this macro, and you will, the compiler will finally get this statement, that is, okay, if will also be included here. I am just specifying this argument. Okay, so it will get if a is less than 10 and b is less than 10. So this will be the final code which the compiler get after pre-processing. So this is how you can have the different in different ways you can use the preprocessor directives. Okay, similarly we can also use the macro like function like macro. So macro we have already seen, macro substitution. So we can also, so in the earlier examples we have seen the simple preprocessor directive that have const and identifier defined and there its value. We can also use the function like macro. Okay, it means the identifier as a macro which you are going to define are used as the function. So here the with the identifier, in order to make the difference, with the identifier we have to use the function call operator. So if I use hash define let sum, then this will be the simple macro or object like macro, and when if I put the parenthesis, so it will become the function like macro. This is the difference, and then we can specify the code for this. So the function like macro which we define can be used in 3 ways, and the first one is the without any argument, and macro with some argument, and the nested macro as well. Okay, so we will see this with example. So let's say I want to define a simple macro. And I call it sum. So here I am going to directly call the sum. Okay, so you will get the value. So that is because we have to use a plus b here, and this one is not required. Although we do not usually use this kind of macro, so instead of this we could have also used the simple macro as well when we are not providing the argument. But still, if you want it to look like a function, then you can use the parenthesis. Okay, the another way is to include a macro which is having some argument. So let's say we are going to calculate area. Then we can call this macro. And then we call the macro circle area and then pass the argument x. In the same way we use function. Okay, I have specified in the small letters, so you can use the small letters as well, but usually in C programming the macros are, it is the standard set in which says that you should define with the capital in order to distinguish. So but you can use the small letters as well, there is no issue. Okay, so first let's save, compile, %f, sorry. Okay, so you will get the answer. Okay, so what happens here is this we call this macro, and within this macro we pass this x. Okay, so here this macro will pass the value of x in R, and then it will be replaced with this code. Okay, so basically it does not actually pass the value, but it will consider the R as the x as the R. So after the compilation, the compiler will get the code something like this. Okay, so this is the macro substitution. So this is how this value, this macro will be substituted with this, and we have already defined the value of x. So whatever argument you pass in this, so the macro will consider that argument as R and replace that code based on that argument. Okay, then we can also have the nested macro. Nested macro simply means it is the parameterized function like macro, but we can use a macro within the macro. We have already seen one example when we use the object like macro with AND, but here I'm going to show you with the function like macro. So let's say I want to define a macro square. This is x into x. And I define another macro, cube. Okay, so cube you have already, square we have already calculated. So we can use square x and then into x. Okay, so this will give the x into x, and then we multiply another x. So although we have used the nested macro, but you would be able to use both of them as well. If I only want square, so I could call macro square, and if I want to use cube, okay, so you will get both. Okay, so when the compiler compiles this code, so what happens is this will be translated into x into x, and when we use this macro, so this macro will be first translated into square x into x, and after this it will again do the translation or the substitution, and finally we will get x into x into x. So this is how the macro works. Okay, so you can use these kind of macro function like macro to define any operation that you want to perform, such as, let's say, if you want to find the minimum value between the two numbers. So we can define the macro as minimum, and here we are going to use the two variables. Okay, so you can have any number of parameters defined with the macro as well. So that is why I wanted to show this example. You can have any number of arguments or parameters defined for the function like macro. And how we can specify the condition? So we cannot directly, if we use the if statement, then it will be very lengthy code, but you can use the conditional operator as well. So what I'm going to do is, if a is less than b, then I wanted to return a, otherwise b, and then I put this whole into bracket. So we do not actually require any value here, variable. So I just directly call the minimum with the values, and that is 10, 20. Okay, so you will get the minimum value. Okay, if I specify this as 80, then also you will get the minimum value, because here b is the minimum. Similarly, like the macro substitution which we have used, the nested macro definition which we have used. Similarly, you can also use the nested macro calling. So within the minimum, I am also going to specify you will now get 10. Okay, so you can have more number of nesting. I can have here minimum, another minimum as well. Let's say 3, 4. Now with the same macro, you would be able to get the minimum. Although the code, the logic we have written is for the 2 numbers, but you can get the minimum from the 4 number or any number, as much as number you want, by having the nested. So minimum is 3, the result is 3, so you can clearly see that the minimum is 3. Okay, so when this code is compiled, so I think you would now be able to understand. So first, this minimum, this will be translated to let us try to decode this. The whole code will be translated to this one first. If 80 is less than minimum of 10, comma minimum of 3, 4, A, B, and then this will be further translated into 80, and then 10 less than minimum of 3, 4, A, B, something like this. Okay, so this is how the code is replaced, and finally you will get something like this. A is less than B. Okay, this is the first condition. Okay, so first is, sorry, 80 is less than, then for the second we are checking 10 is less than, for this we are checking 3 is less than 4. If 3 is less than 4, then 3 will be written, otherwise 4. And if this is written, then it will return either 10 or the result of something like this. So this is how the translation works. Okay, although it will take time to write the whole code. Okay, this is how the macro substitution works, and we can use the nested function like macro. The another type of macro is or the another type of preprocessor directives are the conditional compilation directives. Okay, so these directives are basically used to uh, give the give the compiler tell the preprocessor program to include the whether to include which kind of code based on the condition defined using these directives. So these directives are basically used to include code based on some condition. In simple terms, we can say. So right now, the directive which we have seen, they include code without any condition. Okay, so they if you define, suppose if you use the define directive, so it will include all the code whenever you use the identifier. But let's say if you wanted to define, include the code or use the macro based on some condition, then in that case we use the compilation control conditional compilation directives. Okay, so we will see this with an example. So here are some directives which are listed here which we can use. So this one is, so first one is the hash if, and second one is the hash def, hash if def, and then hash if and def, then hash else and hash elif. Okay, and there is one more directive, hash and if. So total number of 6 are used. So the hash if directive is used to check the constant expression. Okay, if it is true, then the code after this directive will be executed, otherwise nothing will happen. Okay, so you can consider this with the if statement which we have learned. Then if defined directive is used whenever you want to test whether a particular macro has been defined or not. If the macro is defined, so basically this directive is used to search whether the macro has been defined. If the macro is defined, then then it will return true, otherwise it will return false. The opposite to if def is if and def directive, and the if and def directive does the opposite. If the macro is not defined, then it will return true, otherwise it will return false. If the macro is defined, the else directive can be used with the if directive, if def or if and def, and basically you can use this directive to define what operations to perform when the condition is true or false. In the same way, we use else in the if statement. Similarly, else if directive are used to check multiple condition. In the same way, we use else if condition in the simple conditional structure. Okay, so this directive is also used either with the if hash if def or if and def. Okay, and if directives are also used to pair as the closing directive for the if or the if def or if and def directives. So as you can see, the example is given here. If we use hash if, then we must close it. Similarly, here also the nested example is also given here. So this is our main, and within the else we have another if and if. We will see these with an example. So let's say I have a macro then I can use if you compile this and then execute. So you will see. So I have given a very simple example of how you can use this. So this is how you can use. So based, you can specify, you can check test for some condition, and based on that condition you can decide whether to execute which code or not. Okay, so in this the next directive we are going to look is if def. So this is used to check whether a directive is defined or not. So if this condition is true, then I can say that A is defined. Otherwise, I can write as A is not defined. Okay, so here we have A defined. If I remove this, compile, then you will get A is not defined, because we haven't, here we do not have any definition for the A. So this is how you can use. And the NDEF if not defined works in the opposite way. So here A is defined, so this will return true. Okay, this directive will return true, and we can have the message A is defined. And A is, if NDEF directive works in the opposite way, so it will check if not defined A. Okay, you can decode it in this way: if not defined A. So we can write that A is, we can write A is not defined. Okay, because it does work in the opposite way, so we have to change the values as well. Okay, so if A is not defined, then it will return true, otherwise it will return false. So because A is defined, so in this case this will return false, and because this will return false, so else part will be executed. Okay, so A is defined. If I change, give it some name, then you will get the message A is not defined. So this is how the macro substitution work. Okay, so this is all about the preprocessor directive, and one use case I want to give you, although there are many, and you must be asking yourself why and how and in which case this could be used. So there may be various use cases even when we write compiler, uh, so or the system program, so these type of directives are used. So I'm just going to show you one way or one use case which I have already implemented. So hope that will be helpful for you to understand. Okay, I have written one embedded C code, and in that I have used uh, this directive, although right now I have commented it, but you can understand through this example. So here what basically I am doing is I have different, the board which I am using, it is basically this board. Okay, so there are other versions of this board are also available. Okay, so this is the board, microcontroller board, and other versions of this board are also available. And as you can see here, these are the different models. Okay, these are the different models. So currently I am using this model. So if I want to write a custom code in which whether you allow others to use any kind of model, then you need to use some directive like this. So for example, I have included this, although I am not using this models, that is why I have commented it. But if I want to uh, make this code applicable for the current model which I am using as well as this model, so for this model I need to change some pin settings. So for that I have defined this preprocessor directive. So when I compile this code, so this code will be used for the AI Tinker board, but instead of the AI Tinker board, if I use the ESP-I board, then these settings will be applicable. So in this way, if I use the other board, so this code will be compiled and will be used for that particular board. So it automatically identify which kind of board and then make those settings for the pin for that particular board. So this is one of the use case which you can use for the preprocessor compilation control directives or conditional compilation directives, you can see. So this is all about this topic, and in this topic you have learned what are the preprocessor directive types of directives, and we have also seen how we can implement the directives in our code. Thank you all. If you have any question, then you can ask. Yes, Abhishek, just a minute. Yeah, you can unmute yourself and ask a question.
Hello, good morning, sir.
Good morning. Good morning.
Sir, my question is, what is the use of directive PRAGMA? Pragma, I think.
Pragma directive. Okay, Pragma directive is basically it is not. Uh, uh, I mean, you can use in the GCC as well, but it is not for the purpose which we use in the other C, uh, the standard Turbo C. So the Pragma directive is basically
Yes, sir.
also used to give the different commands for the to the compiler. For example, whenever we execute our C program,
Mhm.
so what happens is the main function is executed first.
Yes, sir.
Okay, but let's say you want to execute some other function instead of main function. So at that time you can use the pragma directive. So you can direct the compiler which function to execute before main function and which function to execute after the main function. So this is this kind of task you can do with the help of pragma directive, and the pragma directive contains something known as the startup and the exit command for this kind of task, and there are various other tasks also which you can perform using the pragma directive, but those are only limited to the turbo C compiler, and GCC does not allows us to do something like that. So basically we can say that the pragma is the special purpose directive which is basically used to turn on and off certain features uh, of the compiler. Okay, so for that purpose it can be used, and
Sir,
the two commands which we can use I have already shown. Yes.
is it possible to change the calling of function main?
Is it?
Is it possible to call any other function before main function?
Yes, yes, you can call
So is
using
it
the
possible
pragma in
from?
turbo C. You can.
Okay, okay.
Hello.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Okay.
Sir, second
Yes, it.
question is, yes, sir. I have
Uh,
second question. So in the scenario of has defined pi 3.14, is it
mm,
will create any memory or not?
it will.
It will create any memory or not?
Yes, yes. When you actually execute the code. Okay. So when the executable file is created and when we execute our program, so that value should be present in the main memory, so it will obviously occupy the space.
It means it's implicitly create the memory. Hello.
Yes, when you execute the code, so that well, because what the directive does is it basically replace that value within the code. So finally when you are going to execute your program, and if your program works on certain types of values, then those values should occupy memory space, then only you can use those values, right? So whenever you execute the code, so it will occupy the memory
So
if the
question
value is there.
is it the question is that is it implicitly creates memory when we
Yes, it.
define? Yes, yes, sir.
Mhm. Implicitly you means, so implicitly means it automatically creates the memory for the
Yes, sir.
value when the code is being executed.
Suppose pi
Yeah, so when the
has
code is
defined.
executing.
Yes, sir.
Uh-huh.
So suppose
Yes.
has defined pi 3.14. It will create floating value, variable, and
Yeah,
if I will
floating
create
for floating value. So
yes, if I will create some other value is integer type, then it will or implicitly create integer type or float type.
yes, yes, definitely it will create.
Sir,
Okay,
having
because
another question.
let
Yes,
me
sir. Yes, sir. Yes,
yeah,
sir.
let me just clearly explain you more clearly.
Okay, sir.
Okay, so whenever we create a variable, this occupies the memory, right? And
Sir, yes.
we store the value, then that value will be stored in the memory location. Okay, but you also know that if I use something like this and I use x plus 45, okay, so what the result you are going to get?
10 plus 45.
10 plus 45,
45.
correct? Yes, so you are going to get 55. So did I specified any variable for this 45?
No.
No, but it is still in memory because I am using it in the code as the constant right now. Like,
Yes, sir.
right?
Yes, sir.
So that is why it has to be in memory. Then only your program could be able to use. So the
Got it, sir.
same thing
Got it.
happen.
Yes.
The same thing will happen with this define, right?
Yes, sir. Yes, sir. Sir, my another question is that is it mandatory to create and .h for file inclusion?
No, not mandatory. You can use #c as well, .c as well. I mean the C source file as well, and include the code in from that file also.
Okay. Thank you, sir.
Okay. Yes. Any other question? Anyone else? Good question, Abhishek.
Thank you, sir.
Thank you, sir. If still learners have any doubt, then they can put it on the discussion board.
Sure.
Thanks, everyone. Have a nice day.
Thank you, everyone. Have a nice day.